Let's review points, lines, and slope. Slope is known as the rise over the run, which really means the rate of change in your function, the ratio of the change in y to the corresponding change in x. And in terms of a formula, the change in y over the change in x. Slope tells us something about what's happening graphically. Positive slope means that our line rises, our function is increasing as we move from left to right. Negative slope means that our line is falling or decreasing from left to right. And slope 0 means that y isn't changing. That means we have a horizontal line. Now if we have a vertical line, which means x isn't changing, then in our formula, x2 minus x1 is 0. So I would be attempting to divide by 0, which is never a good idea. So in the case of a vertical line, we say that the slope is undefined. Let's look at an example. I have 2 points, 1, -2, and 3, 2. And if we connect these points with a line, I get something kind of like that. And the slope, of course, is going to be positive because this is an increasing function. And what is that slope? It's the change in y divided by the change in x values. And 4 divided by 2 tells me that the slope of this line is 2. Now if our line happens to cross the y-axis, we call the intersection point the y-intercept. This is a special point. It's where the line crosses the y-axis, the y-intercept, and we abbreviate it with the letter B. Everyone's favorite equation form for a line is y equals mx plus b. M is the slope, b is the y-intercept. So for example, if I know that my line has slope -2 and I know the y-intercept is 1, then the equation for the line is y equals -2x plus b. b is 1. Now if I have my equation for the line given, say, in some kind of general form, maybe like this, we can rearrange and solve for y. So for example, we could subtract 3x from both sides and divide by 4. And what do I see from writing the equation this way? Well, it's in mx plus b form. It's in slope form. So m, which of course is the slope, I can see it's right here. It's -3/4. And b, the y-intercept, I can see in this equation it's sitting right here, 6/4, or if you like, 1.5 or 3/2. Now what if I have the slope and a point but not an intercept, just a regular point like 4, 2? What do? Well, if we rearrange the definition of slope, we get an equation that looks like this, point-slope form. So our point is what we've labeled x1, y1 in the formula, and our slope again is what we're calling m. So point slope says y minus y1 is m times x minus x1. So plugging in for this example, y minus 2 is 2/3 of x minus 4. Don't forget those parentheses, that's important. Okay, and so this is an equation, and it is describing the line that we're interested in. Now there are a lot of ways we could rearrange this equation into different forms. For example, I could take this equation and multiply through by 3. So let me take this same equation and let me multiply the left-hand side and the right-hand side by 3. Just to clear out the fraction. Okay, so I'll have 3y minus 6 on this side, and 2/3 times 3 is just 2. So I've got 3y minus 6 equals 2x minus 8, and let me add 8 to both sides. 8 minus 6 is 2. And let me move the y over to the right-hand side, and let me flip the whole thing and write it as 2x minus 3y equals 2. That's sometimes called general form, where I just have these coefficients that are integers. And we could also write this in slope-intercept form, and it doesn't matter what equation I start with here. All the equations on this slide are describing the exact same algebraic relationship, the exact same line. They're just written differently. So it doesn't matter which one I use here. Let me grab the most recent expression we had and subtract x from both sides. We're solving for y now. So let's divide by -3 and get 2/3 x minus 2/3. And so here we see it in slope-intercept form. You can see that the slope is 2/3, which we already knew that, right? That's how this problem got started. We assumed that the slope was 2/3. But now I can also see the y-intercept. This line crosses through the point 0, -2/3. We've talked about what to do if you have the slope and the y-intercept, and we've talked about what to do if you have the slope and some other point. What do I do if I have just 2 points? We'll break it into 2 steps. Step 1 is going to be find the slope using the definition of slope. Find m. And then step 2 is you have the point and you have the slope. In fact, you have 2 points, but you certainly have at least 1 point, and you have the slope. So I could use point slope or one of the other formulas if you like. But I could use point slope, for example, to get the equation of the line. So, for example, here are my 2 points, 2, 3, 4, -1. Step 1 is what's the slope? M is -1 minus 3 over 4 minus 2. The slope is -2. And now we can use any of our other equations to get our hands on the equation for this line. For example, I could use y minus y1 is m times x minus x1 and plug in either of these points, 2, 3, or 4, -1. Doesn't matter. Either one will give me the same relationship. Let me grab the first one. So y1, let me use this as my example. So 2 is x1 and 3 is y1 and m is -2. So y minus 3 equals -2 times x minus 2, and that's an equation for this line. And if you want to write it in a different form, we could solve for y. Y is -2x plus 4 plus 3 is plus 7. And we can always double check our answer here by plugging in our original points. If x is 2, then -2 times 2 is -4 plus 7 is 3. That's correct. And if x is 4, plugging that in, -8 plus 7 is -1. That's correct. So this equation is satisfied by both points, and so I know it's correct. I know this is the line that goes through the 2 points. One final comment about 2 special cases. If you have a horizontal line, that means that y doesn't change, that y is constant. So if y is equal to k somewhere, y actually equals k everywhere. And in fact, that's the equation for a horizontal line. The slope is 0, and so y is k, which would be the same as b, the intercept. Y is a constant. A vertical line means that x is constant. X doesn't change. So x is always equal to, in this case, what I've called h. And that, in fact, is the equation for a vertical line.